course, is just a fancy word for fraction. So if you have a rational exponent, which I'm going to have in these questions today, it literally just means your exponent is a fraction. Okay, now these rules in terms of the exponent properties, which we're going to use first, work the same way as regular exponent properties. It's just going to be a situation where you have fractions that you're dealing with. Okay, so normally, my very first question, I have a division question, and normally I'm like, okay, where do we have more x's, the top or the bottom? Or maybe in this case, I'd say, where do we have more 2's, the top or the bottom? It's a little trickier to do that when your exponent is a fraction. So I'm going to use the actual exponent property. Does anybody remember the actual exponent property if you are dividing? Like, what do you do with the exponents if you have like bases? And my bases are both 2 here. Remember what you do with the exponents? Subtract them. Okay, so the base here, this is a 2. So in this case, this is nice for us. If I subtract fractions, which I'm going to do here, it'd be 2/3 minus 1/3. I do need a common denominator, but we have one here, so we don't need to create a common denominator. So I'm just subtracting those. So that would simplify to be 2 to the 1/3 power. That's all you have to do. Like bases, the base in this case, I use numbers for each one of these. This would work with variables too. But what we're going to do is we're just going to subtract the exponents. Numerator, subtract the denominator exponent. Now, if you multiply like bases, these are both 7's, you're going to add the exponents. But if you're working with fractions, we actually have to have a common denominator. So what would I do to be able to add, just raise your hand and tell me, like what would you do to be able to add 1/2 and 3/8? Yeah. Yes. All right. So you just got to make them have the same denominator. So the less work, the better. That first fraction, right, if I multiply top and bottom by 4, we're not changing the expression. We're just manipulating it for our purposes. So you guys would agree 4/8 is the same thing as 1/2, right? We're basically like unreducing the fraction to help us add these together. Now, when you actually add them, don't change the denominator. So this would be 7. You just go ahead and add across the top, be 7/8. If you do, I don't have it on these two questions here, but if you do end up with a numerator that's bigger than the denominator, don't change it to a mixed number on any of these questions. Okay, now, the next two are a little tricky. So I don't have like bases in the next question. So I have 2 to the 1/2 power times 16 to the 3/4 power. So if you don't have the same base, what you want to do is try to create the same base, and then we can use our exponent properties. Okay, so the smaller number here is 2, right, to the 1/2. Can you write 16 as 2 to a power? You can't. That little yellow sheet might come in helpful. 16 is 2 to what power? Does anybody know? The 4th. Okay, so here's what I'm going to do. I'm going to rewrite this as 2 to the 4th, and this is going to then involve 2 exponent properties. So on that second term there, I have a power to a power. I have 2 to the 4th, 2 to the 3/4. In that case, if you have a power to a power, you're going to multiply those exponents. I'm going to just write it up here to the side. So I'm going to take 4 times 3/4, right? Power to a power. I would just write the 4 over 1. If you are multiplying fractions, you do not need a common denominator. In this case, this is going to be 12 over 4, which actually means the exponent on that second fraction would actually be 3. So I have 2 to the 1/2 times 2 to the 3rd. The goal there is to be able to simplify as much as we can. So if we can get them to be the same base, then we can go ahead and multiply these. So in this problem, for my base, I'm going to do 2. We're going to do 1/2 plus 3. And I'm just going to turn 3 into a fraction by writing it over 1 really quick. Now, to get a common denominator here, it's going to be top and bottom by 2. So I would have 2 to the 1/2 plus 6 over 2 would reduce back to being 3, so I know that looks good. And then I'm just going to go ahead and add those exponents. So it would be 7 over 2. And again, don't change that to a mixed number. If your numerator is bigger, that's totally fine. Just leave it as an improper fraction. And then I've got one more here that has a negative exponent, but you got to have the same base. If they're not the same base, you can't just add the exponents. So I have a 5 to the 1/3. I'm just going to copy that. Can anybody think of how to write 25 as 5 to a power? What do you think? Heck yeah, 5 squared. All right, now, don't worry about the negative. We'll deal with that in a second. So power to a power there, I'm going to multiply those exponents. So that 2 is going to get multiplied by negative 1/3. Now, if you want to just, you don't have to, but just write it over 1. That actually is just going to give you negative 2/3 as the exponent. So I have 5 to the 1/3 times 5 to the negative 2/3. If you are multiplying like bases, we're just going to add the exponents together. So this is going to be, we don't have to create a common denominator here. So I'm going to do 1/3 plus a negative 2/3. Now, I end up, if I subtract that there, we get negative 1/3. Not considered simplified if we have a negative exponent. Literally all you have to do with a negative exponent is just, we're going to turn it into a fraction just real quick. So move it and lose it. This would just be 1 over 5 to the 1/3 power. Not considered simplified if you have a negative exponent. So I'm just going to go back and box my answers in here. So some of these might be super quick. Some of them might take you a minute to do. But if you are multiplying like bases, you're going to add exponents, and you need a common denominator if you have to add fractions. If you're dividing, you're going to subtract the exponents. And again, if you subtract, you have to have a common denominator. If you do power to a power, though, you don't need a common denominator. You just multiply. Okay, now, works the same way with variables here. So, like if I have x to the 5/6 times x to the 1/4, my base here is x. So I would add 5/6 and 1/4. What would you use as a common denominator between 6 and 4? I'd probably use 12. You could use 24 if you want to. 12 would be a little smaller to work with. So let's see, top and bottom here by 2, top and bottom here by 3. So I would have 10/12 plus 3/12. And then you just go ahead and add those. Keep the denominator the same once you got it. So this would be the 13/12 power. Now, I put these last two in because these trip people up. So I'm multiplying, right? I have 8x to the negative 2/3 and 10x to the 5/8. Okay, the only thing that's being taken to the power is the x, not the numbers. So when you simplify this, we're actually going to just multiply 8 and 10 together. Like, just multiply the numbers, all right? Multiply the numbers, and I'm going to add the exponents on the letters that are the same. In this case, my bases are both x. So you're going to have an 80 out in front, and then we're going to combine those two fractions. Let's see, what can we use as a common denominator between 3 and 8? I think it's got to be 24, right? I can't think of a lower number. They both go in. All right, so top and bottom here by 8, top and bottom here by 3. You just keep that 80 out in front. Those are just plain numbers that we're multiplying together. Now my exponents are going to become 16 over 24 and 15 over 24. So keep the 80, keep the x, and then once you've got the common denominator, just straight across the top, 16 and 15 will give you 31. And then if you would get something you could reduce, you're allowed to do that, but 31 and 24 don't have anything in common. Yeah. Oh no, what did I screw up?
I think it's -2. So
Oh, it's negative. Fired. Okay, negative. You're so right. Okay, so fired. Okay, let's see. That would be negative 1 over 24. Now, in this case, I didn't finish the problem. So you're going to take the negative exponent, which is only on the x. So I'm going to leave the 80 on the top, and then x to the positive 1 over 24 would go on the bottom. Sorry about that. That 2 is negative. Don't move the 80, though, because that doesn't have a negative exponent. Only the x does. Similar with division. All right. So if you have just plain numbers, I just have a 5 and a 10 here, right? That reduces to 1/2. Now, for my exponents, I have x to the 3/5 and x to the 3/4. So, like bases, I'm just going to kind of write this to the side. I'm going to subtract exponents. And it does matter the order. Whatever the exponent in the numerator has to go first, and you're going to subtract the exponent in the denominator. And then again, we got to get a common denominator. Let's see, between 5 and 4, I think we're going to have to use 20. So top and bottom here by 4, top and bottom here by 5. I'm just working with the x at the moment. This would be 12 20ths minus 15 20ths. So we get -3/20. All right, so if that's the case, when I write my answer, that 5/10 reduces to 1/2. I'm going to have a 1 left in the top, 2 in the bottom from the 1/2, and I'm going to move that negative exponent would be 3/20 is going to be in the denominator with that 2. Is anybody having a question? Okay, now the rest of what we're going to do today is take an exponential form, which means I have an exponent that's a fraction, and we're going to convert it to radical form, so like a square root, cube root, fourth root, whatever. So I'm going to give you basic definition here, and I just got my rational exponent a/b. I call this bottom out to help me remember it. What happens though, the bottom or the denominator of the fraction is going to flip out and become the index of the root. There's 2 ways to write this. All right, so this is x to the a/b. This is the b root of x to the a. The numerator is going to stay with whatever your base is there. The denominator, I just call it bottom out. It goes out and it becomes the index of the root. Now, I will write them like this, but I just want to show this to you. Technically, you can also write it in this format where you would take the b root of whatever that base is and then to the a power after. Those are the same thing, it's just different notation. So I just want to show you like a really, well actually we'll do this on the first problem here. We're going to do these, and when you guys get to the test and quiz on this section, it's going to ask you to be able to do this without a calculator, but you can use that little yellow piece of paper because it might be helpful to you. So this is 64 to the 1/2. All right, I'm going to bottom out, so this is going to become a square root. Usually we don't write the index, but I'm going to do it for this problem. This would be the square root of 64 to the 1st. What's the square root of 64? Okay, yeah, no, I'm glad you said that. He said plus or minus 8. In these questions, that 1/2 power is already there. I'm not introducing that, so I'm not technically introducing a root. I'm just converting it to radical form. So really, really glad you said that. Don't put a plus and minus. So if this is positive, we're just going to write, this is just going to be positive 8. That's all this is. If you guys notice that, if your exponent is like a 1 over something, if you just have x to the 1/2 power, that is just the same as a square root. If you have like x to the 1/3 power, that's just the same as a cube root. So if your exponent has 1 on the top, you're going to just be taking a root. If it has another number, we're going to have to do an extra step. That's going to be what we're going to do in our next question. Okay, so bottom out. I'm going to do, this would be the square root of 4 to the 3rd. Okay, we're doing these problems by hand. Here's what I would tell you to do. Take the root first, because sometimes the number might be bigger than 4. What is the square root of 4? 2. And then apply the exponent, which is going to be the 3. So I'm taking the square root of 4, and then I'm going to take that to the 3rd power. Actually, my answer for this question is also going to be 8. So if you do that, do the root first, because it's going to be working with a smaller number, and then do the exponent when you're done. If you have one like I have next to this, literally the only thing this would just be 1 over 343 to the positive 1/3 power. So we're just going to have a fraction for our answer. So I'm going to put 1 over, and I'm going to do my bottom out. This would be the 3rd root of 343 to the 1st. Anybody know that's just a cube root? Cube root of 343? 7, yeah. And use that little yellow piece of paper if that helps you in any way. But that's all it's going to be if you got a negative exponent. Now this last one, I really want you to think about it. So I have negative 8 to the 2/3 power. So I'm going to do the cube root of negative 8. And then I'm going to do that bottom out. So the denominator's 3. So that's going to become the index of my root. And then I'm going to square that. So if I take the cube root of negative 8, we can do that, right? Cube root of negative 8 is going to be negative 2. I'm going to just take the root first and then do the exponent. What do you get when you square negative 2? Positive 4. Like the negative is going to cancel out there, so that last answer is 4. Is anybody having a question about converting those numbers to radical form? And I'm just going to try a couple others. Now, these have exponents that are written as a decimal instead of a fraction. Anybody know how I've got 25 here. How could I convert 1.5 to a fraction? Or does anybody know what that is as a fraction? It's 3/2. Totally right. And then you can do your bottom out. If you're like, what the heck, where did you get that? If you're ever not sure, if you have a decimal, like this is 1.5, 5's in the tenths place. If you're ever not sure, you can take that number. I'm going to write that as 15 since it goes to the tenths place. I just put it over 10. If you reduce that, and you can use your calculator if you want to do that, but both of those numbers are divisible by 5. So I'm going to do my bottom out. So my denominator becomes the index. So this is the square root of 25, and then we'll take that to the 3rd power. So what's the square root of 25? 5. And then, you guys know 5 to the 3rd? 125? Yep, good. Okay, you can tell me what 0.8 would be as a fraction. And if you're ever not sure, like I said, that 8 is in the tenths place. You could just do 8/10, see if you can reduce it. Should be 4/5. Okay, but bottom out. Now this maybe up on the board or that yellow paper might come in handy. I'm going to do the 5th root of negative 32. And then once we get that, we'll take that to the 4th power. Anybody know 5th root of negative 32? Should be negative 2. Good. All right. And then what will happen there, if that's even, I got negative number to an even power. That'll cancel out the negative. Negative 2 to the 4th should be positive 16 as your final answer there. Okay, now I'm just going to do one more. So power to a power, I'm going to multiply the exponents. So this is going to be 2 times negative 1/3. You do not need a common denominator to multiply fractions together. So this is going to be negative 2/3 here. So I have really 216 to the negative 2/3 power is really my problem. Okay, now remember, negative exponent does not mean negative number, does not mean you can't do it. It just means we're going to turn it into a fraction. So this is 1/216 to the 2/3 power. So my answer is just going to be a fraction, just 1/, and I'm going to see if you guys, this one's a little harder. So we're going to do bottom out, cube root of 216, and then we'll square it. Does anybody know the cube root of 216? 6. Okay, so this is going to be 6, and then we'll square it. So that should be 36. So when I just write my answer, it's just 1/, that because of our negative exponent. Is anybody having a question? Okay, those were all numbers. I'm going to mix in some variables here. So I think I wrote this on the front, actually. So x to the 1/2, this is just the square root of x to the 1st, or I would just write, you don't have to write that exponent, but the bottom out works with the variables too. If you have a 1/3 power, x to the 1/3, it's just the cube root. Those two things are the same. Now, these other two. All right, so I'm going to do my bottom out. So this would be the 4th root of x to the 3rd. Or if you like that other notation, you could do the 4th root of x and then take that to the 3rd power. I probably would recommend the first one. And I'm going to do one more, but this one's very tricky. Okay, now I have x to the 3 over 2 power. So this would be the square root of x to the third. Okay, now, here's the one thing I'm going to tell you, and it didn't happen on any of the other questions. If your exponent, which is 3 for this one, is bigger than that index of that root, then that can be simplified. So if this number exponent on the inside is bigger than the index, you can simplify this. So I'm not totally done with this problem. So if I was going to break this down, the biggest number up to 3 that 2 would go into, I would do x squared times x, just to break that down a little bit, because I can take the square root of x squared would come out as an x. So this question is really tricky, but it would be x times the square root of x to actually put that in radical form, totally simplified. And that doesn't happen on every question, but just to give you an example. Okay, now, these ones underneath here, I'm going to do the bottom out, but these have actually exponents within the little set of parentheses. So when I do the bottom out, I'm going to do the third root, and I'm just going to keep this in parentheses, a to the 5th, b to the 7th, and then that numerator has to go as an exponent on the inside. Now, if you're working with a plain number, not variables, if you're working with a plain number, I would tell you to take the root first. In this case, I would tell you, let's simplify the exponent on the inside first. All right, so if you're working with variables, simplify on the inside first. These are both situations where you got exponent property, bless you, power to a power. So I'm going to multiply the exponent with the power on the outside there. So a to the 5th twice would really be a to the 10th. And b to the 7th twice would really be b to the 14th. If your exponent, which for both of these variables it is bigger than the index of the root, it can be simplified. So this is a cube root that we're working with here. I want the biggest number up to 10 that 3 would go into and 14. So I would do, for the a's, I would do 9 and 1, and for the b's, I would do 12 and 2. I'm just trying to get the biggest exponent I can that would be divisible by 3. And we have to, when we break it apart, that exponent property is that you add the exponents when you multiply like bases. So if I were to put those back together, that would be 10 and 14. We're just going to remove anything we can. So exponent divided by the root, that would come out as a to the 3rd, b to the 4th. And so we'll have some stuff left underneath here in simplest radical form. My answer would be a cubed b to the 4th, and then left under my cube root, an a and a b squared. When you have what's left underneath, as long as the exponent underneath is smaller than the index, you should be good. You took out everything that you could. All right, I'm going to try one more here. So bottom out, the bottom of the fraction becomes the index on the root. And again, I'm going to keep this in parentheses, x cubed, y to the 6th. Now these guys on the inside, they're going to get that numerator as their exponent, so that's going to be to the 3rd. All right, if you're working with variables, do the exponent on the inside first. So this is the square root. We'd have power to a power. I'm going to multiply these exponents. This would be x to the 9th and y to the 18th. 3 times 3 is 9. 6 times 3 is 18. Now you got to be careful and pay attention what type of root you're working with. So this one's a square root. So if I want to break it down, I need my exponent divisible by 2, which I don't have with the x. So I would break that apart up to 9. The biggest number 2 would divide into would be 8. The 18 on the y, I would just leave that alone. If that exponent is even and you're working with a square root, you've already got a perfect square. So I would not break that apart. We're just going to simplify it. Under a square root, x to the 8th comes out as x to the 4th. Y to the 18th, I'm just dividing the exponent by the index of the root, be y to the 9th. So I got x to the 4th, y to the 9th, and then we do have 1x left under the square root there. Does anybody have a question? Okay, this example will be really quick. So example 4 here, we're going to take radical form and go to exponential form. So it's literally just kind of reversing what we were just doing. So if I have a radical form and I want an exponential form, x just means you have an exponent. So I'm going to reverse the bottom out. So this will be c. Can anybody tell me what the power would be on that if I... 3/4. Yep, that's it. Done. All right. This one's written in that other notation. This is going to be b. Can anybody tell me the power on that second one? What would the power be for the exponent? 5/3. Perfect. Okay, now, these last three all look super similar, so I want to show you the difference between them. This one right here, the only thing being taken to the 5th power is that a. All right, so this inside here is really 6 to the 1st power. And if this helps you in any way, this is a square root, so sometimes I might write the index just to help myself. So if I'm going to write this in exponential form, just the 6 alone, it's just the square root of 6, so I would write that as 6 to the 1/2 power. All right, and then the a would be to the 5/2 power. So it's just writing that in exponential form. Now, the one next to this, there's parentheses around the 6a. So I can just use that, parentheses, and then reverse the bottom out. So that whole thing would be to the 5/2 power. So those two are different because I don't have parentheses around the 6a in that first, or that question in the middle there. The last two, though, they are actually the same. The parentheses around that whole thing, this would just be that, bless you, that other notation. So this last one, the last two actually are the same. They're just two different notations for that. If it's got parentheses around it, I'm going to take the 5th root of that whole thing, but the whole thing is also under a square root. So those last two are the same, but the one that's in the middle of that example is different. Okay, now we're going to put everything together at the bottom here. I've got variables and I've got numbers. So we're going to try and simplify the numbers and simplify the variables too. All right. This is a power on the outside of some parentheses, and inside I have a product. So everybody gets that 3/4 power. So negative 3/4 power. When I work with the a, we got a power to a power there. So I'm going to take that -8 times that -3/4. And if it helps you want to line them up, I can write that -8/1. But my a, we're going to end up with positive 24/4, because when I multiply those exponents, I have a negative times a negative. So 24 divided by 4 is actually a nice number. That's a to the 6th. Now, not simplified because we've got this negative exponent. So we're just going to move this guy down to the bottom. So I have a to the 6th over 16 to the positive 3/4. Now, all you're going to do with the number, we did this in an earlier example, it's just going to be in the bottom of the fraction. I'm going to see if we can simplify this. Try your best to do it without a calculator. So by bottom out, I'm going to do the 4th root of 16 to the 3rd. Do the root first if you're working with a number. You guys know the 4th root of 16? 2. All right, so this is 2, and then you do the power, which is 2 to the 3rd. So the bottom of that fraction is going to be 8. So we had a to the 6 over 8. Okay, very similar. So everybody gets the exponent. So we're going to have 243 to the 2/5, and then power to a power, we're going to do -10 times 2/5, which is going to be -20/5, so -4. So my exponent on the x is going to be a -4. Now, all I'm going to do for that negative exponent is move that down to the bottom. The 243 to the 2/5, that has a positive exponent, so that's going to stay on the top. And when I move it, I'm going to lose the negative on the exponent. So it would be 243 to the 2/5 over x to the 4th. We're just going to see if we can simplify the 243 to the 2/5. All right, so bottom out, I'd have the 5th root of 243 squared. This might not be one you guys are super familiar with. Does anybody know the 5th root of 243? 3. Yeah, all right, so this is 3 squared, so then this will be 9. So when I write my answer here, we'd have 9 over x to the 4th. Just try your best to do those without your calculator. Sorry, this is shaking all over the place today. but try to best to do without a calculator. And then I have one more. All right, so 1/4 power to everybody. So we're going to have 81 to the 1/4. Now, if I multiply it by 1/4, that's the same as just dividing by 4, right? So if I do 28 divided by 4, this is just going to be x to the 7th. And if I do negative 20 divided by 4, it'd be y to the negative 5th. Okay, I'm going to have to make a fraction here because I got a negative exponent. That y to the 5th, we're going to have to move that down. So I have 81 to the 1/4, x to the 7th over y to the 5th. Now, 1/4 power is just the 4th root. Does anybody know the 4th root of 81? Dakota, what do you think? 3, yes, all right. So this is just 3x to the 7th, y to the 5th. Does anybody have any questions? Okay, sorry.